Formative exercise 2.1, questions number 1. The diagram on the right shows a part of graph f of x equal to x squared minus 4x plus 3. A, from the graph, find each of the following. Number 1, the limit when x approach negative 1. So when x approach negative 1 from the left hand side or from the right hand side, the function approach 8. Therefore, the answer for number 1 will be 8. Number 2, the limit when x approach 0. So when x approach 0 from the left hand side or from the right hand side, the function approach 3. Therefore, the answer for number 2 will be 3. Number 3, the limit when x approach 1. So when x approach 1 from the left hand side and from the right hand side, the functions approach 0. Therefore, the answer is equal to 0. Number 4, when the limits approach 2. So when x approach 2 from the left hand side and from the right hand side, the function approach negative 1. Therefore, the answer for number 4 will be negative 1. Number 5, the limit when x approach 3. So when x approach 3 from the left hand side and from the right hand side, the function approach 0. Therefore, the answer for number 5 is 0. Questions B. Find the possible values of a if limit of f of x when x approach a is equal to 8. So here we can substitute the f of x with x squared minus 4x plus 3. As x approach a, then we can substitute the x here with a. So this is a quadratic equation. To solve this, first we need to write this in general form. Therefore, this will be a squared minus 4a. 3 minus 8 is negative 5. This is equal to 0. By using factorization method, next we're going to get a plus 1 and a minus 5. This is equal to 0. Therefore, a is equal to negative 1 and a is equal to 5. Question C1. Determine the gradient of the tangent function dy dx of the graph by using first principles. So here we're going to start with this. So first we're going to input the function with x plus delta x. Therefore, the x here we're going to replace it with x plus delta x. Then we're going to minus with f of x, which is minus bracket x squared minus 4x plus 3. Expand this, we're going to get x squared plus 2x delta x plus delta x squared minus 4x minus 4 delta x plus 3 minus x squared plus 4x minus 3. So here x squared minus x squared will be cancelled. Negative 4x plus 4x will be cancelled. Positive 3 minus 3 will be cancelled as well. Then this will be the delta y. Next, we're going to divide both sides with delta x. So the delta x here will be cancelled. This one just left with 1 and this one will be cancelled. This is equal to 2x plus delta x minus 4. To find the dy dx, we're going to substitute the delta y delta x here with this. As delta x approach 0, then we're going to substitute the delta x here with 0. Then dy dx is equal to 2x minus 4. Number 2. Then determine the gradient of the tangent at point 4, 3. Remember, dy dx is the gradient of the tangent function. In this case, which is the 2x minus 4. To determine the gradient of the tangent at any points, we just need to substitute the coordinate x of that point, in this case, which is the 4, into the dy dx. So here we're going to substitute the x here with 4. So 2 times 4 minus 4. The answer of this is equal to 4. Questions number 2. Find the value for each of the following limit. So always refer to this when you are finding the value for the limit. So for questions A, I'm going to start with the direct substitutions. If the answer is not equal to 0 over 0, then that value will be the answer. For questions A, here as x approach 0, then I'm going to substitute the x here with 0. The answer here is equal to 9, and that will be the limit value for A. Questions B, as x approach 2, then I'm going to substitute the x here with 2. So here I'm going to get cube root of 8. The answer of this is equal to 2. Question C. Here the x approach 9. Therefore, I'm going to substitute here the x with 9. The answer of this is equal to 0 over 0, which is known as the indeterminate form. To find the limit value for C, here we need to use the factorization method. So here, for the 81, I can write this as 9 squared. Next, for the denominator part, I can factorize it using this knowledge. It will be x plus 9, x minus 9. In order to simplify this, for the numerator part, I'm going to factorize it. So here I'm going to use negative as the common factor. Then bracket, here I'm going to get negative 9 plus x. If I rearrange this, then I'm going to get x minus 9. So now I can cancel for the x minus 9. So what left will be negative 1 over x plus 9. So now I'm going to substitute the x here with 9 as x approach 9. This is equal to negative 1 over 9 plus 9, which is equal to negative 1 over 18. Questions D. As x approach 2, so I'm going to substitute the x here with 2. The answer of this is 0 over 0. So to find the limit value for D, here again I'm going to use the factorization method. So here I'm going to factorize for the numerator. This will be x minus 2 and x plus 1. So now I can cancel for the x minus 2. So now I can substitute the x here with 2. This is equal to 2 plus 1. Then the answer will be 3. Questions E. As x approach 1, then I'm going to substitute here the x with 1. The answer of this is 0 over 0. To find the limit value for E, here I need to factorize it. So here we can factorize the numerator. The common factor here is x. So x bracket x squared minus 1. So here we can continue to factorize for this part. So here for the x squared minus 1, I can write this as x squared minus 1 squared. Then when I factorize this, I'm going to get x bracket x plus 1, x minus 1. So now we can cancel for the x minus 1. So now I can substitute the x here with 1. This is equal to 1 bracket 1 plus 1. And the answer of this is equal to 2. Question F. As x approaches 5, then I'm going to substitute the x here with 5. The answer of this is 0 over 0. To find the limit for f, we need to factorize it. So first, we're going to factorize the numerator. This is equal to x minus 5, x minus 2. As for the denominator, we can write this as x squared minus 5 squared. Then when we factorize it, we're going to get x plus 5, x minus 5. So now we can cancel for the x minus 5. So now we can substitute the x here with 5. Then we're going to get 5 minus 2 over 5 plus 5. Then the answer of this is equal to 3 over 10. Question number 3. Determine the limit value for each of the following functions. For A, as x approach 0, then I'm going to substitute the x here with 0. So the answer of this is 0 over 0. To find the limit value for a, here I need to rationalize the numerator. So here the conjugate for the numerator will be square root 1 plus 2x plus square root 1 minus 2x. So when we expand for the numerator, by using this as the guideline, we are going to get 1 plus 2x minus 1 minus 2x. As for the denominator, I just going to leave it as x times square root 1 plus 2x plus square root 1 minus 2x. So for the numerator, 1 minus 1 here will be cancelled. As 2x plus 2x, we're going to get 4x. So next, we can cancel for the x here. So now I can substitute the x here with 0. So this is equal to 4 over 2. Then the answer will be 2. Questions B. As x approach 4, then I'm going to substitute the x here with 4. So the answer of this is 0 over 0. To find the limit value for B, here I need to rationalize the numerator. So here the conjugate for the numerator will be 3 plus square root x plus 5. So here when I expand for the numerator, by using this as the guideline, here we're going to get 3 squared, which is 9, then minus x plus 5. As for the denominator, I'm just going to leave it as x minus 4 times 3 plus square root x plus 5. So here when we solve for the numerator, we're going to get 9 minus 5, which is 4, minus x. So here, in order for us to cancel the numerator with the x minus 4, so here I'm going to factorize the numerator. So here I'm going to use negative 1 as the common factor. Then I'm going to get negative 4 plus x. And if I arrange this, it will be x minus 4. So now for the x minus 4, I can cancel this. This is equal to negative 1 over 3 plus square root x plus 5. As x approaches 4, then I'm going to substitute the x here with 4. Then the answer of this is equal to negative 1 over 6. Question C. As x approaches 3, then I'm going to substitute the x here with 3. So the answer of this is 0 over 0. To find the limit value for C, here I will need to rationalize the denominator. So here the conjugate for the denominator will be 2 plus square root x plus 1. So for the numerator part, x squared minus 5x plus 6, this one we can factorize this. The answer will be x minus 3 and x minus 2. Then times 2 plus square root x plus 1. As we expand for the denominator, by referring to this, 2 squared we're going to get 4, then minus x plus 1. So for the denominator part, 4 minus 1 we're going to get 3, then minus x. In order for us to simplify the denominator with the x minus 3, so here we're going to factorize the denominator with negative 1. This will be negative bracket negative 3 plus x. So here, if I rearrange negative 3 plus x, this is the same as x minus 3. So now I can cancel for the x minus 3. Then this is equal to negative bracket x minus 2 times 2 plus square root x plus 1. So now I can substitute the x here with 3. So this is equal to negative 4. Questions 4a. Given that the limit value of x squared minus k over 3x minus 6 when x approaches 2 is equal to 4 over 3, finds the value of k. So first I'm going to try with the direct substitutions. x approach 2, then I'm going to substitute the x here with 2. Here you will notice that the answer for the denominator is equal to 0. This means by direct substitutions, we are not going to get the limit value of 4 over 3. But direct substitution will result in indeterminate form, which is 0 over 0. So here, by doing the comparison, 2 square minus k, this is equal to 0. 4 minus k equal to 0, then k is equal to 4. So to get the limit value of 4 over 3, then we will need to factorize this. So for the numerator, this number 4, we can write this 2 square. Then when we factorize for the numerator part, here we're going to get x plus 2 and x minus 2. As for the denominator, we're going to have the common factor of 3, then 3 bracket x minus 2. So now we can cancel for the x minus 2. So now when we substitute the x here with 2, then we're going to get 2 plus 2 over 3, which is equal to 4 over 3. Questions 4b. If the limit value of x squared minus 2x minus h over kx plus 2 when x approach negative 1 is equal to negative 2, finds the value of h plus k. To find the value of h and k, so here by direct substitutions, I'm going to assume that the answer is equal to 0 over 0, which is the indeterminate form. So here I'm going to substitute the x here with negative 1. So next I'm going to get 1 plus 2 minus h over negative k plus 2. This is equal to 0 over 0. Next, 3 minus h over, so for the denominator, I'm going to rearrange this as 2 minus k equal to 0 over 0. So now by doing comparisons, 3 minus h equal to 0. Then h is equal to 3. As for the denominator, 2 minus k equal to 0. Then k is equal to 2. To confirm that the answer of h and k are correct, I'm going to substitute it back into the limit. So here for the numerator, I can factorize this as x plus 1 and x minus 3. As for the denominator, I can factorize it as 2 bracket x plus 1. So now I can cancel for the x plus 1. As x approach negative 1, then I'm going to substitute the x here with negative 1. So here I'm going to get negative 1 minus 3 over 2. So the answer of this is negative 2. So here we can confirm that the answer of h equal to 3 and k equal to 2 are correct. Then the value of h plus k is equal to 3 plus 2, which is equal to 5. Questions number 5. Differentiate the following functions with respect to x by using first principle. A, y equal to 5x minus 8. So for questions 5, I'm going to assume that y is equal to f of x. So differentiate using first principles, always start with this. So first, I'm going to substitute x plus delta x into the x here. This will be 5 bracket x plus delta x minus 8. Then I'm going to minus with f of x, which is going to be 5x minus 8. Expand this, 5x plus 5 delta x minus 8 minus 5x plus 8. So here 5x minus 5x will be cancelled, as well as negative 8 plus 8. Then delta y is equal to 5 delta x. Next, I'm going to divide both sides with delta x. Then the delta x here will be cancelled. Then delta y delta x, this is equal to 5. To find dy dx, we're going to substitute the delta y delta x here with 5. So here, as we don't have delta x to replace with 0, then dy dx is equal to 5. Questions B. Y equal to x squared minus x. So first I'm going to substitute the x here with x plus delta x. So here we're going to get bracket x plus delta x squared minus x plus delta x. Then we're going to minus with the f of x, which is the y, which is going to be bracket x squared minus x. So next we're going to expand this x squared plus 2x delta x plus delta x squared minus x minus delta x minus x squared plus x. So here x squared minus x squared will be cancelled, negative x plus x will be cancelled. Then delta y is equal to 2x delta x plus delta x squared minus delta x. So next I'm going to divide both sides with delta x. So here the delta x will be cancelled. So what left is going to be 2x plus delta x minus 1. To find dy dx, I'm going to substitute the delta y delta x here with this. As delta x approaches 0, then I'm going to substitute the delta x here with 0. Then the answer of the dy dx is equal to 2x minus 1. Question C, y equal to x plus 1 square. For question C, before we start with the delta x, so here I'm going to expand this first. So y equal to x squared plus 2x plus 1. So now I'm going to substitute x plus delta x into the x here. So this is equal to bracket x plus delta x squared plus 2 times x plus delta x plus 1. Then I'm going to minus with the f of x, which is the y, minus bracket x squared plus 2x plus 1. Next, expand this x squared plus 2x delta x plus delta x squared plus 2x plus 2 delta x plus 1 minus x squared minus 2x minus 1. So here x squared minus x squared will be cancelled, 2x minus 2x will be cancelled, and 1 minus 1 will be cancelled. So this will be the delta y. Next, I'm going to divide both sides with delta x. So the delta x here will be cancelled. This is equal to 2x plus delta x plus 2. To find dy dx, substitute the delta y delta x with this. So next, substitute the delta x here with 0. Then the answer of dy dx is 2x plus 2. Questions D, y equal to 1 over 4x. So first, I'm going to substitute the x here with x plus delta x. This is equal to 1 over 4 bracket x plus delta x. Then we're going to minus with f of x, which is y, 1 over 4x. To solve this, here I will need to equalize the denominator. So this is equal to x minus delta x over 4x bracket x plus delta x. So here x minus x will be cancelled. So this will be the delta y. Next, I'm going to divide both sides with delta x. So this is the same as you multiply by 1 over delta x. So the delta x here will be cancelled. This is equal to negative 1 over 4x bracket x plus delta x. To find dy dx, substitute the delta y delta x with this. Next, substitute the delta x here with 0. Then the answer of the dy dx is equal to negative 1 over 4x squared. Questions number 6. The displacement of the squirrel running on a straight cable for t seconds is given by s of t equal to t squared minus 3t, where t is greater than or equal to 0. By using first principles, find the velocity of the squirrel when t is equal to 5. So here we're going to differentiate s with respect to t. So here instead of delta y, here we're going to get delta s equal to s with the input t plus delta t minus s of t. So first we want to substitute t plus delta t into the t here. So this will be t plus delta t squared minus t times t plus delta t. Then minus with s of t, which is going to be bracket t squared minus 3t. Expand this, we're going to get t squared plus 2t delta t plus delta t squared minus 3t minus 3 delta t minus t squared plus 3t. So here t squared minus t squared will be cancelled, as well as negative 3t plus 3t. So this will be the delta s. Next, we're going to divide both sides with delta t. So here the delta t will be cancelled. So this is equal to 2t plus delta t minus 3. To find ds dt, which is the velocity, we're going to substitute the delta s delta t with this. As delta t approach 0, so substitute the delta t here with 0. Then ds dt is equal to 2t minus 3. So when t is equal to 5, to find its velocity, we're going to substitute the t here with 5, as ds dt is the velocity. This is equal to 2 times 5 minus 3, which is going to be 10 minus 3, and the answer is equal to 7.